right, guys, let's go through this review. Okay, number one. Number one says, if f double prime of x is x times x plus 1 times x minus 2 squared, then the graph of f has inflection points of what x values. So first of all, inflection points lets me know second derivative is equal to 0. So thankfully I was already given the second derivative. I don't have to solve for that or do any deriving, but these are just possible points of inflection. They don't guarantee that they are inflection points. So I still need to make a sign chart to make sure that there is a change. A change in inflection happens when you go from the plus to minus or minus to plus. So I need to test them. First of all, I'm going to set this equal to 0. 0 equals x times x plus 1 times x minus 2 squared. Take each factor, set it equal to 0. X equals 0. X plus 1 equals 0. X minus 2 equals 0. So my zeros are 0, -1, and +2. Again, I would need an actual change in sign of my second derivative for it to be a point of inflection. These are just possibles. These are maybe it happens here, maybe it doesn't. So I'm going to put these numbers on a sign chart and see if I have any change. Here, these are numbers around my points of inflection. So less than -1 is going to be -2. Between -1 and 0 is going to be -0.5. Between 0 and 2 is 1, and bigger than 2 is 3. Again, I'm looking for a change in sign of my second derivative. So I'm going to plug it into my second derivative. My second derivative is x plus 1, x minus 2 squared. So just a sign is all I care about. When I plug in a -2 in for x is going to be a negative number. When I plug it in a -2 for -2 plus 1, it's going to be a negative number. When I plug it into the third one is squared, so it's always positive. So I have a negative times a positive gets me a positive number. Same thing with the -0.5. -0.5 in x is a negative. -0.5 plus 1 is a positive. Third one is squared, it's always positive. So negative, positive, positive, there's a negative. Plug in 1. 1 in for x is a positive. 1 in for x plus 1, that's a positive. And my third factor is squared, so it's always positive. That's a positive. Do it with 3. 3 in for x is a positive. 3 plus 1 is a positive. 3 minus 2 is a positive. It's squared anyway. It's always going to be a positive. So you're looking for a change. So you went from up to down or down to up. That happens here between up to down. Here is a point of inflection. And then going from down to up, and this stays up. So there is no change at 2, there's another change at 0. So my points of inflection are x equals -1 and 0 only. That would be letter C. So you have to test them and find out. Number 2. Number 2 says the maximum acceleration. So first of all, if I am going to try to maximize acceleration, I need to derive acceleration. There's no way to find the maximum of it without deriving it. I was given an interval between 0 and 3, and then I was given a velocity. My velocity is t cubed minus 3t squared plus 12t plus 4. So I need to be able to derive acceleration in order to find out what the maximum could be. Again, if I'm actually looking for the actual maximum of the acceleration, I'm going to have to plug back into the acceleration eventually. I'm not looking for where it happens or when it happens. I'm looking for what is the actual maximum acceleration. So I'm going to derive this. The velocity derivative is the acceleration, and that would be 3t squared minus 6t plus 12. So there's acceleration. I want to maximize this, so I need to derive it. I get 6t minus 6. Set it equal to 0. 0 equals 6t minus 6. Add the 6. T is 1. So this is a possibility for where it could occur, the maximum acceleration. If I want to know what actually the highest acceleration this particle obtains, I have to test both the start value and the end, the outer, and I need to test the value I just solved for, my critical value. So I'm going to plug them back into my acceleration function. So I would have 3 times 0 squared minus 6 times 0 plus 12. That gets me 12. I would have 3 times 3 squared minus 6 times 3 plus 12. That's 27 minus 18. That's 9. 9 plus 12 is 21. And then plug in 1. 3 times 1 squared minus 6 times 1 plus 12 is 3 minus 6. That's negative 3 plus 12 is 9. And I want the actual maximum value itself. It is a 21. So D. You were looking for the actual maximum itself, not when it happens. Number 3 says relative minimum. So now I don't have endpoints to test, whereas number 2 wanted the actual maximum, so you needed to test the ends. Here I just want a minimum. Doesn't have to be the lowest, it just wants a minimum. So I was given a function, f of x, 2x cubed minus 3x squared minus 12x, and I wanted to find a minimum. So if I'm trying to find a minimum value, going to derive, set it equal to 0. So my derivative here is 6x squared minus 6x minus 12. Set it equal to 0. I have 6x squared minus 6x minus 12. I'm going to divide everything by 6. 0 equals x squared minus x minus 2. And now I'm going to factor. I'm looking for factors of negative 2 that add to negative 1. That would be negative 2 and 1. So x minus 2, x plus 1. My zeros are 2 and negative 1. These are the x values. It wants to know which one of these is a minimum. So I'm looking for a minimum at an x value. That's the other thing to be wary of. This one wanted the x, not the y. I don't actually care what the minimum is. I just want to know where it is, what x value. So I have 2 values that could possibly give me a minimum. And if you see they're both on the multiple choice answers, I need to make a sign chart and see which one is actually going to give me a minimum. So numbers around these numbers, smaller than negative 1, negative 2, between negative 1 and 2, 0, bigger than 2, 3. Plug them into the derivative. So I have, it is x minus 2 and x plus 1. So negative 2 minus 2 is a negative number. Negative 2 plus 1 is a negative number. Negative times a negative is a positive. 0 minus 2 is a negative. 0 plus 1 is a positive. That's a negative. 3 minus 2 is a positive. 3 plus 1 is a positive. That's a positive. I'm looking for a minimum. A minimum happens when you go from down to up. So I'm looking for negative to positive. So if I was to draw along this, this would be increase, this would be decrease, this would be increase. My minimum happens here at x equals 2. It's where you change from going down to going up. That is letter C. Number 4. Let f be a function with the second derivative, f double prime, is x squared times x minus 3 times x minus 6. What are the x coordinates? So x equals question mark for the points of inflection. Points of inflection, let me know my second derivative equal to 0. Test them for change. Remember, you can get a possible point of inflection or a possible extrema and it not actually be a max or a min or a change in concavity. It's just a critical value for whatever reason. So I have 0 equals x squared times x minus 3 times x minus 6. So my x's are 0, 3, and 6. What's going to make each one of those factors individually 0? So notice that 0 only is an answer, 3 only is an answer. You got doubles and you have all 3. Chances are it's not all 3. That wouldn't really make sense, but we can try and see. I make a sign chart. I'm looking for change. I've got 0, 3, and 6. Test around them. I'm going to test -1, 1, 4, and 7. And here you're plugging into that second derivative, which was x squared, x minus 3, and x minus 6. So when I plug in -1, no matter what, when I plug it into the x squared, it's positive because any number squared is positive. -1 minus 3 is a -1. -1 minus 6 is a negative. So I have positive, negative, negative, positive. Plug it in the 1. 1 squared is positive. 1 minus 3 is negative. 1 minus 6 is negative. Still positive. So that right there tells you 0 is not a point of inflection. I didn't have a change. I go from concave up to concave up. It's probably just a little dip in the graph. I don't know. It's just not a point of inflection. Plug in 4. 4 squared is a positive. 4 minus 3 is a positive. 4 minus 6 is a negative. Negative. Plug in 7. 7 squared, positive. 7 minus 3, positive. 7 minus 6, positive. I'm back to positive. So I go up, 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 down, up. So my points of inflection happen where the change happens, at 3 and at 6. So that is D. D is 3 and 6 only. Number 5. The function g of x is equal to 4x cubed plus 3x squared minus 6x plus 1 has an absolute, that lets me know I'm using my endpoints, absolute minimum on the interval -2 to 1. What is the absolute minimum? So first of all, minimum lets me know first derivative equal to 0. I want to know what the actual minimum itself is. So actual min lets me know it is a y value. So I'm going to have to plug back in. So I'm going to derive this once. Derivative of g is 12x squared plus 6x minus 6. Set it equal to 0. 12x squared plus 6x minus 6. I'm going to divide all these numbers by 6. So I have 2x squared plus x minus 1. Now I'm looking for factors of -2 that add to a positive 1. 2 and -1. My factors are not x plus 2 and x minus 1. That is because of this 2 out front. So I'm going to put them both over 2. Put the reduced version back into my factor. So 2 over 2 is a 1. I've got x plus 1. This one doesn't reduce, x minus 1/2. Truthfully, the factor is 2x minus 1. So that's why it doesn't look like this would multiply back out and give me 2x squared if I was to FOIL there. But for our case, we're going to end up solving for the 0 anyway. So if you solved for the 0, x would still be 1/2. So it doesn't really matter which way you put it back in. Oh my God, my smartboard just turned off on me. Our school is fantastic. Please hold. And we're back. So again, I don't have to put it in full factored form because we really only care about the zeros. So find out what the 0 is, plug it back into the factors. My zeros are a -1 and a positive 1/2. So which one is the absolute minimum? So I'm going to have to plug in not only the endpoints, but my critical values into, these are my critical values, into my g function. I'm looking for the minimum value of g. So you're plugging back into g. I'm going to do my ends, g of -2, g of 1, and then my critical numbers, g of -1 and g of 1/2. And there's no way I'm putting 1/2 into anything in my head. So I am going to go to my calculator here and plug these in. When I plug in -2 to g, here is g. I get 4 times -2 cubed plus 3 times -2 squared plus minus 6 times -2 plus 1, you get -7. When I plug in -1, 4 times -1 cubed plus 3 times -1 squared minus 6 times -1 plus 1, I get 6. When I plug in Oh, that was -1, so that's the one underneath it. Now I'm going to plug in regular 1. When I plug in +1, 4 times 1 cubed plus 3 times 1 squared minus 6 times 1 plus 1, I get 2. And now when I plug in 1/2, I get 4 times 1/2 cubed plus 3 times 1/2 squared minus 6 times 1/2 plus 1. I get a -0.75. I was looking for an absolute minimum, so it would be the -7, which is answer option A. Next page. Number 6, trig. The function f is defined by sine x plus cosine x between 0 and 2 pi. X coordinate, x equals question mark for the point of inflection when it goes from down to up. So concave down to concave up. First of all, point of inflection, I'm going to find that by second derivative equal to 0. Down to up would be from negative to positive in that second derivative. So I'm going to have to derive this twice. Trig, our favorite. So first derivative, derivative of sine is cosine. Derivative of cosine is negative sine. Do it again. Second derivative, derivative of cosine is negative sine. Derivative of sine is cosine. So I have negative sine x minus cosine x. This I'm going to set equal to 0 and use my unit circle to solve. So I have 0 equals negative sine x minus cosine x. This is not going to be helpful for me. I'm going to have to figure out something to get sine and cosine on opposite sides. So I'm going to add cosine x to both sides. And I have cosine is equal to negative sine. So I'm going to look for somewhere on my unit circle where my coordinates are the same, but one is positive and one is negative. So if I'm going to do that, I need to first know what my unit circle looks like. So I'm going to quickly just sketch a little unit circle for us, and we will be able to do that. So here we go. My coordinates are square root of 3 over 2. Just don't know what I say, not what I do. Square root of 3 over 2, 1/2. Square root of 2 over 2, square root of 2 over 2, and 1/2 square root of 3 over 2. And then this is a 0, 1. And then it flips. I have negative 1/2 square root of 3 over 2. Negative square root of 2 over 2, square root of 2 over 2. And then negative square root of 3 over 2, 1/2. This is negative 1, 0. Now they're both negative. Negative square root of 3 over 2, negative 1/2. Negative square root of 2 over 2, negative square root of 2 over 2. Negative 1/2, negative square root of 3 over 2. And then one more time, now just my y value is negative 1/2, negative square root of 3 over 2, square root of 2 over 2. Neither of this, x is not negative. Square root of 2 over 2, negative square root of 2 over 2, and then square root of 3 over 2, negative 1/2. My coordinate here is 1, 0. So places where my numbers are exactly the same with opposite signs are here and here. Let's figure out what those radians are. This is 0, pi over 6, pi over 4, pi over 3, pi over 2. This is 2 pi over 3. This is 3 pi over 4. So that's one of my answers. This is 5 pi over 6. This is pi. 7 pi over 6. This is 5 pi over 4. This is 4 pi over 3. And 3 pi over 2. Oh, I skipped this coordinate. 0, negative 1. And then this is 5 pi over 3. I have a 7 pi over 4. There is my other answer. And finally, 11 pi over 6. So x is 7 pi over 4 and 3 pi over 4. Now, these are not both my answers. Obviously, my answer can only be one of these things. So I'm going to make a sign chart to figure out which one of these things it is. Ooh, I can't believe I grabbed almost all of it in one shot. And you know, I'm not going to edit this video, so this is going to stay. Okay. So now I'm going to make a sign chart to see which one of these is where it changes from concave down to concave up. So concavity, second derivative, 3 pi over 4 and 7 pi over 4. Something else we don't really like is doing these things without a calculator, but I can guarantee you this would be a no calculator question. So I'm going to choose numbers around 3 pi over 4. Well, here's 3 pi over 4. A number smaller than that has some nice coordinates, is pi over 2. Between 3 pi over 4 and 7 pi over 4, a number between them that has some nice coordinates is pi. And then bigger than 7 pi over 4, choose 2 pi. They've got nice 0 and 1 versions of coordinates. So I'm going to plug it into my second derivative, which was negative sine x minus cosine x. So I have negative sine of pi over 2 minus cosine pi over 2. Pi over 2 is up there at 90 degrees. My negative sine is my y value, cosine is my x. Negative sine would be a negative 1 minus cosine minus 0, negative number. Sine of pi, negative sine of pi minus, I'll do this in blue. Negative sine of pi minus cosine pi. Well, sine of pi is negative 0 minus cosine negative 1. This would be a positive 1. Positive. Okay, plug in 2 pi. Negative sine of 2 pi minus cosine 2 pi. Negative 0 minus 1, back to negative. So I wanted to know where it goes from concave down to concave up. So from negative to positive, there it is right there. X is 3 pi over 4. That is B. Number 7, we already did in class, so we'll talk about it again. 7 says f is defined in the closed interval, so that means it's bounded from A to B, and it has no max. So if you have something that isn't ever going to have a highest value, you have a straight line. There is no way, this is the only option, there is no way to not have a highest value unless it's a straight line. Even this, if I say, okay, this only has a minimum, wrong, these are maximums. There's no way to only have one extrema on a closed interval. Now, if the interval was not closed and I had arrows on the sides of my graph, then sure, I could only have a maximum or I could only have a minimum. But that's not this scenario. I have a closed interval from A to B. There must be a top. There must be a bottom. That's why it's C. There is no minimum. Number 8. For what values of x, so x equals question mark, does the graph of y equals 3x to the 5th plus 10x to the 4th have a point of inflection? Point of inflection is second derivative equal to 0. Test them. So I'm going to derive twice. First derivative, y prime, 15x to the 4th plus 40x cubed. Derive again. 60x cubed plus 120x squared. Is that equal to 0? 0 equals 60x squared plus 60x cubed plus 120x squared. I'm going to factor straight from here. Pull out 60x squared. I'm left with x plus 2. My zeros are 0, negative 2. Need to see which one of these gives me an actual change in inflection, or maybe they both do. Negative 2, 0. Numbers around them. Negative 3, negative 1, 1. Plug them into my second derivative. It was 60x squared times x plus 2. So if I plug into x squared, no matter what, it's a positive. So no matter what this number is, it's a positive. And then -3 times, or -3 plus 2 is a negative. This is a minus. 60x squared, positive no matter what. -1 plus 2, positive, positive. 60x squared, positive no matter what. 1 plus 2, positive. I want to know point of inflection, so I need to change. This is down, this is up, that's still up. No change at 0, only at 2. That would be B. Number 9. Let f be the function defined by 2x cubed minus 3x squared minus 12x plus 18. On which of the following intervals is f both decreasing and concave up? So decreasing, that is a first derivative characteristic. Concavity is a second derivative characteristic. First derivative is negative, is decreasing. Slope is negative. Second derivative, concavity, is positive. So let's test them. We got to do a ton of work here. First derivative, 6x squared minus 6x minus 12. I'm going to just go straight and find my critical numbers right here. 0 equals 6x squared minus 6x minus 12. Divide everything by 6. 0 equals x squared minus x minus 2. And factor. Factors of -2 that add to -1. -2 and 1. X minus 2. X plus 1. My zeros are 2 and -1. So let's find out where I'm decreasing. Sign chart. -1, 2. Test numbers around them. Smaller than -1, -2. Between -1 and 2, 0. Bigger than 2, 3. And plugging into right here, x minus 2, x plus 1. So -2 minus 2 is a negative number. -2 plus 1 is a negative number. Negative times a negative is a positive. 0 minus 2 is a negative number. 0 plus 1 is a positive number. All right, here's where I'm negative. 3 minus 2 is a positive. 3 plus 1 is a positive. Positive. I want to know where it's decreasing. So here is where I'm decreasing. I'm going to decrease from x equals -1 until x equals 2. I need to also see where I am concave up. So I got to derive again. My first derivative's up there, 6x squared minus 6x minus 12. So my second derivative is 12x minus 6. The 12 drops off. I have 0 equals 12x minus 6. So 6 equals 12x. X is 1/2. Test that. 1/2. Number smaller. 0. Number bigger. 1. I'm plugging into 12x minus 6. 0 times 12 is 0. Minus 6 is a negative number. 0 times 12 is 12. Minus 6 is a positive number. So I am looking for concave up. I'm concave up from 1/2 to infinity. So the only overlap between -1 and 2 and 1/2 to infinity is 1/2 to 2. And if you're not sure how to do that, draw yourself a number line. 1/2 to 2, this is D. The number line I'm talking about is, here's my number line. I'm decreasing from, here's 0, -1 to 2. This is my decreasing interval. I'm in concave up from 1/2 forever. Where do they overlap? Right here. 1/2 to 2. It's letter D. Number 10. F double prime is x times x plus 2 squared. And the graph is concave up where? So first of all, concavity, second derivative, up, positive. So I've already been given my second derivative. I don't have to do any deriving. That's nice. I'm going to set it equal to 0. That's where my concavity changes would take place if they do. So that means that x is 0 and x is negative 2. Make a sign chart to see where my second derivative is positive. If my second derivative is positive, I'm concave up. So numbers smaller than negative 2, negative 3, between negative 2 and 0, negative 1, and bigger than 0, 1. I'm going to plug this into x times x plus 2 squared. So negative 3 out front is a negative. My second one is always positive because I have a square. Anything squared is positive. Negative times a positive is negative. Negative 1 out front, negative. Second term, always positive. Second factor, always positive. Negative. 1 out front, positive. Second factor, always positive, positive. I am only concave up from 0 till forever. So x is greater than 0, which is B. Number 11. The function f has a derivative. So this is my derivative function. X cubed minus 4x. At which of the following does the graph of f have a point of inflection? So point of inflection is second derivative equal to 0. Test them to see which ones actually are a point of inflection. So I was given my first derivative. I only have to derive one more time. F double prime of x. This is 3x squared minus 4. Set it equal to 0. 0 equals 3x squared minus 4. I'm going to add 4 to both sides. 4 equals 3x squared. Divide by 3. 4/3 equals x squared. Square root. So I typically would say square root of 4/3. If you look at your answers, they square root the 4 and give it a 2 and leave a square root of 3 on the bottom. Obviously, we only have one answer, so that's got to be it. C. We could plug it back in and test it, but none of the other options are there. We don't have any other options. And there is none. If there was like a this doesn't exist type of an option, you might want to test that to square root of 3, 2 over square root of 3. But since this is my only option, that's all I can do. So, problem done. Number 12. Let f be a function with a first derivative of 3x squared minus 6 over x squared, for x is greater than 0. I know that f of 1 equals 9 and that f of 3 equals 11. For what value of x in the interval from 1 to 3 does it satisfy the mean value theorem? Again, my mean value theorem says that my slope equals my derivative somewhere. I'm trying to find out where, no matter what, it is equal at some point in the interval. So slope is y minus y over x minus x. Derivative, I was given a derivative, 3x squared minus 6 over x squared. Plug in some numbers. Y minus y, 11 minus 9 over x minus x, 3 minus 1, right? These two are y's, these two are x's. Is equal to my derivative, 3x squared minus 6 over x squared. 11 minus 9 is 2. 3 minus 1 is 2. I haven't done anything to the right side yet. 2 over 2 is 1. 3x squared minus 6 over x squared. I'm going to try to get rid of my fraction. So denominator is division. I'm trying to get rid of the division. Do it through multiplication to cancel out. X squared equals 3x squared minus 6. I'm going to add 3x squared to both sides. sorry. I'm going to subtract 3x squared to both sides. So I have negative 2x squared equals negative 6. Isolate the x squared divided by negative 2. X squared equals positive 3. Square root both sides. X equals square root of 3. This is option B. So you have to know the mean value theorem. This should be a pretty basic problem. Yes, it takes a second to do, but you just plug and chug. It's gonna happen. You just have to figure out where. Mean value theorem will always hold true for any continuous differentiable function. And 13. The function f has a first derivative of x to the fourth minus 6x squared minus 8x minus 3 on the intervals. On what intervals is it concave up? Concavity is second derivative. So where is my second derivative? Positive for concave up. So I have a first derivative already. Derive again. And it specifically is talking about f being concave up. If it said where is the derivative concave up, you would derive twice. But since it says where is f concave up, you want the second derivative of f. So that's kind of the play on words that we talked about with like the velocity and all of that stuff. Look at what it is that you're trying to look for concavity for. Concave up for f, second derivative of f. So second derivative is 4x cubed minus 12x minus 8. So say this was a non-calculator question and you didn't know how to find the zeros of this, because a lot of you don't, which is common. If I didn't teach math, I wouldn't know how to do it either. First of all, I'm going to divide everything by 4. So I have 0 equals x cubed minus 3x minus 2. It looks like a quadratic. It's a little bit misleading. But if you're not sure, look at your answer options. A is 2 to infinity. B is 0 to infinity. C is negative 1 to 2. D is negative infinity to negative 1 and 3 to infinity. So these numbers, 2, 0, negative 1, and 3, those would have to be points of inflection, which means that my derivative, second derivative, would be 0 there. So if all else fails and you don't know how to factor this, plug those numbers in and see which ones give you 0. So when I plug in 2, I would get 2 cubed minus 3 times 2 minus 2. 3 times 2 minus 2, yeah. So I would get 8 minus 6 minus 2. That gives me 0. So one of my points of inflections is definitely 2, or a possible point of inflection. Plug in 0. 0 cubed minus 3 times 0 minus 2. That gives me a negative 2. Not a point of inflection. B is definitely not an answer. Plug in negative 1. Negative 1 cubed minus 3 times negative 1 minus 2. This gives me a negative 1 plus 3 minus 2. There's 0. Another point of inflection. And the last one, plug in 3. 3 cubed minus 3 times 3 minus 2. This is 27 minus 9 minus 2. Not 0. Automatically makes that not an answer. So that also helps for, like, if you are short on time, or, I mean, if you're short on time, hopefully you're not doing this. But if you are just a deer in headlights and don't know what to do, this can help you to at least narrow down some answers. Wow, that did not work for me at all. All right, so now I'm going to, now that I can have determined what my critical values or points of inflection, are, make a sign chart and see where it's concave up. So my possible points of inflection are 2 and negative 1. So negative 1, 2, choose numbers around them, negative 2, 0, and 3. And I'm plugging it into my second derivative, which is x cubed minus 3x minus 2. Wow, okay, no, I did that right. almost cried and thought that was an 8. So let's plug in -2. -2 cubed is a -8. Minus 3 times -2, that's a +6. Why isn't this working? Oh, it does work. -2. That's -10 plus 6, which is a negative number. Plug in 0. 0 cubed minus 3 times 0 minus 2. That's a negative number. And 3. 3 cubed minus 3 times 3 minus 2. This is 27 minus 9 minus 2. That's a positive number. Concave up. I'm only concave up from 2 to infinity. So that's A. 2 to infinity only. And that's your whole practice test. I will give you some nostalgia here and say, and we're done.